You're listening to Science and Stillness, where knowledge drifts softly into sleep. Tonight, the solar system itself becomes a gentle companion. Not a place of roaring storms or impossible distances, but a quiet network of worlds held together by motion, balance, and the spaciousness between them. The central thought guiding this night's journey is simple. Cosmic calm arises from the quiet balance between motion and emptiness. Every orbit, every pale arc of light, every drifting particle participates in that equilibrium, like threads of a tapestry woven slowly enough to soothe the breath. As the mind settles, the vastness above becomes an open field where nothing rushes. Planets follow their paths with unhurried precision. Moons trace soft loops. Even sunlight walks outward in patient waves, crossing billions of kilometers without ever raising its voice. In this script, each step through the solar system widens that sense of spacious calm, revealing that the universe's enormity is less a source of fear and more a cradle of gentle rhythms. Let the body soften. Let attention loosen. The night opens, and a pale world unfurls softly, as though waking in its own time. The quiet shape of the solar system emerges slowly, almost as if the universe itself is taking a long breath. From afar, everything seems still, but what looks like stillness is really an immense choreography. Worlds drifting along paths carved by gravity, each moving at a pace so steady that the motion becomes a kind of cosmic lullaby. In this gentle beginning, the sun glows at the center, not as a raging furnace, but as a calm and constant lantern whose light unfurls in every direction, thinning softly as it travels through the deep dark. Its brightness is what allows the planets to be known at all. Without it, they would be muted stones in an endless night. With it, they shimmer with quiet signatures, each responding to the light in its own way. Astronomers describe gravity as a curvature in space-time, a bending of the cosmic fabric that guides planets into traveling circles or ellipses rather than lines. Yet it helps to imagine it another way tonight, as a slow and invisible tide. This tide presses gently, encouraging every world into a rhythm it can keep for billions of years. Nothing snaps or pulls abruptly. Everything leans, adjusts, and settles with patience. The sun's mass creates the largest swell in this tide. The planets respond not with struggle but with trust, entering their orbits the way drifting boats follow the broad pull of an ocean current. In this immense balance between motion and emptiness, calm arises not because things are static, but because their motions are steady and predictable, a harmony sustained by the simplest rules of the universe. The emptiness between worlds is not a cold void here. It is soft space, the quiet medium through which light travels and planets glide. If one could shrink small enough to ride along beside a beam of sunlight, there would be no sound and no wind, only a feeling of endless openness. That sense of space is part of the solar system's serenity. Most of it is not crowded with matter. Instead, it is spacious enough that each world has room to trace its path without interruption. Even the asteroid belt, often imagined as a dense cluster of tumbling rocks, is mostly empty. If you were drifting through it, you might never see anything drift past. This surprising emptiness is not a lack of life, but a source of gentle order, letting motion unfold cleanly and without collision. From this perspective, the planets feel less like isolated spheres and more like markers placed on a vast circular garden. The inner ones sit close to the sun's warmth, moving quickly as they complete short orbits. Their paths are tight and bright, swept by sunlight that arrives with strength. Farther out, the giant worlds drift slowly, taking many years to complete one loop. Their long, graceful arcs are stretched across a wider sweep of darkness, where the sun is only a pale glow. These differences in speed do not create conflict. They create texture, layers of rhythm at different tempos, braided together like a quiet musical piece with slow, deep notes and soft, fast ones woven through. The idea that calm emerges from motion might seem counterintuitive at first. On Earth, movement often feels like disturbance, yet the universe teaches a different lesson. When movement is steady, balanced, and measured across immense scales, it becomes soothing. It becomes the background hum of existence. Each orbit in the solar system is a testament to this truth. The Earth's year is not merely a count of days. It is a smooth curve around the sun. Mars takes longer, Jupiter much longer still. But all these paths are stable, and stability on such large scales produces a kind of cosmic quiet that filters down through time, shaping the environments of planets and moons. Even storms, when seen from afar, contribute to this harmony. Jupiter's swirling bands, Saturn's shifting clouds, and the ethereal winds on Neptune all follow long-lasting patterns maintained by rotation, pressure, and heat. They are not bursts of chaos. They are sustained motions that settle into structure. The Great Red Spot, for example, is a storm older than modern science itself, yet its presence feels less like violence and more like the slow turning of a giant wheel. Over centuries, it drifts, changes color, expands, contracts, never in haste, always in a rhythm almost too slow for human senses to detect. When magnified in a telescope, its shape suggests power, but when placed in the context of time, it suggests patience. The sun, too, follows long cycles. Its surface flickers with granules and eruptions, yet these movements compose patterns that repeat every 11 years, a rise and fall of magnetic activity that has persisted for millennia. From the perspective of a single human life, these cycles feel subtle, but on cosmic scales they are reliable beats in the solar system's ongoing music. It is this reliability that brings calm, not stillness, but the expectation that motions will continue gently, without sudden breaks. Imagine drifting slowly above the plane of the solar system, hovering where gravitational pulls from all the planets cancel into a delicate balance. Below, the orbits form faint rings of light, as if painted onto a vast disk. The inner rings glow brighter, the outer ones dimmer. Everything moves, but nothing rushes. Mercury loops around quickly, tracing its path in a matter of months. Neptune takes so long that civilizations rise and fall before it completes a single lap. Yet in the grand view, both planets are simply part of the same pattern. Fast or slow, each contributes to the sense of steady drift. Humanity has often sought comfort by looking upward, because the heavens display the kind of constancy that life on Earth rarely provides. Seasons change because Earth tilts and circles the sun. Tides rise and fall because the moon pulls on the oceans. These motions repeat with a dependability that has guided cultures for thousands of years. Calendars, rituals, and agricultural cycles all echo celestial rhythms. When people long ago watched the stars wheel overhead, or the phases of the moon unfold, they were witnessing the same quiet equilibrium that shapes the solar system today. Even if they did not know the physics behind it, they felt its reassurance. In the present age, spacecraft carry cameras and instruments into the solar system, revealing worlds with greater clarity. Paradoxically, the more detail scientists uncover, the more tranquil everything begins to feel. Photographs of Saturn's rings show countless icy particles orbiting in thin bands, each moving according to the faintest whisper of gravity. Images of Mars reveal dust lifting lightly in pale winds. Data from Voyager, still traveling outward after more than 4 decades, show that beyond the planets, the solar wind fades into the calm of interstellar space. All of these discoveries deepen the impression that the solar system is not a place of violence, but a place of long-established balance. Even the early, turbulent era of planetary formation has settled into memory. 4.5 billion years ago, the solar system was a swirling cloud of gas and dust, full of collisions and heat. But over time, friction, gravity, and cooling transformed that chaos into a stable arrangement of worlds. The memory of turbulence exists in craters and tilted axes, in moons captured or formed from impact debris. Yet the present solar system bears little resemblance to its younger self. It has, over billions of years, discovered its equilibrium. Every orbit today is the result of ancient motions that gradually quieted into harmony, much like waves smoothing out after a storm. To understand this calm is to understand that emptiness is not absence. Emptiness provides room for motion to settle, for forces to balance, for light to disperse evenly. Between Earth and the Moon, there is space. Between planets, more space. But that space gives the solar system its signature rhythm. Without it, worlds would collide or influence each other too strongly. With it, they maintain respectful distances, each carrying out its own chapter in the larger story. Tonight, as the mind wanders through this cosmic garden, the focus is not on detail, but on atmosphere. The atmosphere of predictable drift, of spacious harmony, of gentle forces working quietly. The solar system becomes a model of calm not because nothing moves, but because everything moves in ways that complement everything else. Motion and emptiness together create a balanced whole, a reminder that serenity does not require stillness, only equilibrium. In this wide, breathing space, the journey continues, deepening into the next world's soft glow, carrying with it the quiet assurance that the universe, in its vastness, holds more calm than chaos. Orbital motion, when viewed from Earth, can appear simple. Planets wandering slowly across the night sky, tracing gentle arcs against the glittering background of stars. But up close, orbit is a quiet miracle of balance. It is neither the triumph of speed nor the dominance of gravity, but a measured conversation between the two. Each world falls toward the sun just fast enough to miss it, creating a perpetual dance in which attraction and motion keep each other company. This is the heart of the solar system's serenity, a balance so consistent that planets follow the same paths for eons, gliding through space with a confidence that feels almost ancient. Imagine standing beside an invisible curve made of gravitational pull. A planet settles into that curve, and its momentum carries it forward. If it moved faster, it would drift outward. Slower, and it would slip inward. But in the narrow range where both forces align, the orbit holds. It is a precise equilibrium, yet broad enough that worlds endure small nudges, tugs from siblings, the faint drag of solar wind, the push of sunlight, without losing their composure. The stability of orbits is not rigidity. It is resilience, the ability to adjust subtle disturbances gracefully over immense periods of time. This resilience becomes clearer when considering how planets interact with each other. Jupiter, with its enormous mass, sends out gravitational ripples that influence the paths of asteroids and even the orbit of Saturn. Earth and Venus tug on each other gently during close approaches. These interactions resemble the slight adjustments made by dancers as they move around one another, subtle shifts that maintain harmony rather than disrupt it. Over long timescales, these interplanetary influences can shape orbits into patterns called resonances, where worlds align their motions in repeating sequences, like steps in a slowly turning waltz. One of the most well-known examples of resonance occurs in the moons of Jupiter. Io, Europa, and Ganymede follow a pattern where Io completes 2 orbits for every 1 orbit of Europa, and Europa completes 2 for every 1 of Ganymede. This 1-2-4 rhythm keeps their paths stable, preventing close encounters and ensuring that each moon remains in its predictable lane. The same concept appears among planets too. Neptune and Pluto, despite their tilted and crossing orbits, never collide because they are locked in a 2-3 resonance. For every 3 orbits Neptune makes, Pluto completes exactly 2. This mathematical harmony acts like a soft guarantee of safety, a reminder that even when paths seem to intersect, the cosmos arranges its timing with care. Closer to home, Earth's orbit is a model of gentle reliability. Its slight ellipse means that sometimes the planet is nearer to the Sun, sometimes farther. Yet the difference is small enough that our world enjoys steady seasons and mild variations. Over tens of thousands of years, Earth's orbit and tilt shift in slow cycles known as Milankovitch cycles, patterns identified by scientists studying glacial layers and ancient climates. These cycles influence the planet's long-term climate, contributing to ice ages and interglacial periods. But they proceed at such languid paces that they feel almost geological in nature. Each cycle carries the signature of slow cosmic balance, a rhythm measured not in lifetimes, but in epochs. The concept of orbit often conjures images of perfect circles, but most planetary paths are ellipses, gently stretched loops that still maintain beautiful symmetry. When a planet moves closer to the Sun, it speeds up slightly due to stronger gravity. As it drifts outward, it slows. Yet these changes do not disrupt the peace of the system. Instead, they add a soft ebb and flow to orbital motion, like the rise and fall of a breeze. This small variation, predicted by Kepler centuries ago, reinforces the impression that celestial mechanics is less about exact precision and more about natural patterns that flow easily across time. When spacecraft travel through the solar system, mission planners use these orbital principles to their advantage. A spacecraft can swing past planets to gain speed or change direction, borrowing a bit of their motion in what is called a gravity assist. This maneuver is not forceful. It takes place through precise timing and alignment, allowing a small craft to glide through gravity wells the way a stone skips across water. Observing these methods reveals yet another layer of the system's calm logic. Even the journeys of human-made explorers rely on the solar system's steady architecture, as if the cosmos offers gentle pathways for travelers who understand its rhythm. This rhythmic structure becomes even more evident when considering the plane of the solar system. Most planets orbit within a thin disk aligned with the Sun's equator, a relic of the swirling cloud from which everything formed. This shared plane reduces the likelihood of dramatic collisions and ensures that orbits interact in predictable ways. From above, the solar system resembles a slow-turning wheel, its spokes made of planetary paths. Each world follows its arc within this thin plane, contributing to a sense of organized grace. But perhaps the most soothing aspect of orbital mechanics is its timescale. Human experience is shaped by hours, days, seasons. Orbits unfold across years, decades, and centuries. Jupiter takes nearly 12 Earth years to complete a single revolution. Saturn, about 29. Neptune, 165. These numbers are not merely measurements. They are reminders that the solar system operates far beyond the pace of human concerns. Its rhythms are so slow, so steady that they inspire a kind of cosmic perspective, a sense that life's urgency fades when viewed against the backdrop of planetary drift. This perspective deepens when considering how orbits persist for billions of years. Stars age, planets evolve, surfaces change through impacts and erosion, yet the fundamental architecture of the solar system remains. Worlds keep circling, the sun continues to shine, the quiet balance holds, even when astronomical events nudge orbits, passing stars, distant gravitational tugs. The changes play out over such long periods that they scarcely disturb the overarching tranquility. The vast majority of orbital evolution is incremental and predictable, shaped by the same principles that have guided the system since its youth. The emptiness between planets enhances this stability. There is no air resistance, no friction to sap momentum. In space, once a body begins moving, it keeps moving unless something acts upon it. This principle, articulated centuries ago by Newton, underlies the gentle persistence of planetary orbits. The vacuum of space is not hostile. It is supportive, allowing orbits to remain smooth and unbroken. In this way, emptiness becomes a medium for continuity, a quiet canvas on which the solar system paints its paths. Looking closely at orbital paths also reveals subtle beauty. Earth's orbit is nearly circular, meaning the sun stays close to the center of the sky throughout the year. Mars's orbit is more stretched, giving the planet more dramatic seasonal variations. Mercury's orbit is the most elliptical among the major planets, creating a dance of sunrise and sunset unlike anything on Earth. Yet all these variations fall within a peaceful spectrum. None of them throws the system into disorder. Each planet expresses its individuality within the broader framework of harmony. At massive scales, orbital motion creates patterns that resemble gentle spirals. Dust near the sun drifts inward slowly due to radiation pressure and gravitational interactions, forming structures that resemble faint trails. Comets follow elongated paths that carry them into the inner solar system before sending them back to the cold frontier for centuries. These long, looping journeys contribute to the idea that motion in the solar system is not just circular, but cyclical. Everything returns, eventually, to where it began, though the journey may take lifetimes or longer. The balance between motion and emptiness, between gravity and momentum, extends beyond planets to every object in the system. Tiny grains of dust, icy fragments in the Kuiper Belt, and faint rings around distant worlds all participate in this equilibrium. Even the heliospheric boundary, the edge where the solar wind meets interstellar space, follows a vast, smooth curve sculpted by pressure differences. The shape of this boundary shifts over time, but like the orbits of planets, it changes gradually, maintaining an elegant balance between outward flow and the subtle push of the galaxy beyond. From this wide view, the solar system appears as a layered composition of motions interwoven gently through space. It is not a chaotic jumble of objects, but a serene arrangement where each body respects the paths of others. Stability does not mean stagnation. It means ongoing motion sustained by forces that complement rather than compete. This is why the solar system feels peaceful, even when seen through the lens of physics. It is a place where rules produce calm, where predictability gives rise to quiet confidence. As the night deepens, this understanding settles like a soft weight in the mind. The planets continue their unhurried drift, tracing curves laid down before life on Earth began. The emptiness around them stretches out like a vast, silent sea, carrying light and motion without disturbance. Each orbit is a gentle affirmation of the central idea that calm arises not from the absence of movement, but from the presence of balance. And in this balance, the solar system reveals itself not as a distant machinery of stone and gas, but as a vast and patient companion, offering its slow rhythms to anyone seeking rest. The inner worlds of the solar system form a quiet quartet, each shaped by sunlight and stone, each carrying its own rhythm within the larger cosmic balance. They lie close to the sun, where light arrives with warmth and clarity, where the days are bright and the nights short. Yet even here, where the pull of gravity is strongest and the pace of orbit quickest, the sense of calm remains. It arises from contrasts that settle into harmony, from landscapes that change slowly, from histories written across billions of years. Moving from one world to the next feels like walking from room to room in an ancient, silent house, where each chamber glows with its own dim light. Closest to the sun drifts Mercury, a small world that moves so swiftly along its orbit that it circles the sun in just 88 Earth days. Its speed might seem at odds with tranquility, yet this motion is its equilibrium, its way of maintaining distance from the sun's gravity. Mercury is tidally influenced in a curious rhythm. It rotates 3 times for every 2 orbits, creating long, quiet days under a sky stripped of air. Without an atmosphere, there is no wind, no sound, no haze. The sunlight falls directly on bare stone, warming half the planet while the other half rests in cold darkness. There is a profound stillness in this contrast, a world divided quietly between heat and shadow. From orbit, the terrain appears ancient and undisturbed, its craters preserved like fossilized whispers of the early solar system. Mercury's silence is more than the absence of atmosphere. It is the echo of its past. Long ago, when the inner solar system was young and chaotic, impacts were frequent and violent. But time has smoothed that era into memory, leaving only patterns etched in stone. Today, the planet's surface changes so slowly that a human lifetime would pass without visible alteration. In that persistence, Mercury becomes a symbol of how motion and stillness coexist. A fast orbit, a slow landscape, both contributing to the calm architecture of the solar system. A little farther out shines Venus, wrapped in thick clouds that scatter sunlight into a warm, golden glow. While Mercury is silent because it lacks air, Venus is silent in a different way. Its dense atmosphere smothers sound, turning even large events into muffled vibrations. The planet rotates slowly, so slowly that its day is longer than its year. This languid spin alters its winds, tides, and temperature cycles, creating patterns that feel more like slow breathing than active weather. Venus once held mysteries that inspired speculation, and while reality has shown it to be harsh on the surface, its upper atmosphere moves in smooth, predictable flows shaped by heat and rotation. The brightness of Venus in Earth's sky has always been a source of calm. For countless generations, people watched it rise as the evening star or morning star, unaware of the thick clouds beneath its serene glow. The light that reaches Earth is filtered through layers of swirling droplets, softened into an almost gentle radiance. From afar, Venus embodies the idea that appearances can preserve peace, even when inner conditions are turbulent. The planet's gentle shine contributes to the night sky's quiet symmetry, reflecting the sun's light in a way that steadies the rhythm of twilight. Between Venus and Mars lies Earth, the only place where motion becomes breath, where cycles of light and shadow sustain life. Yet Earth is part of the same cosmic balance as the other inner worlds. Its orbit is nearly circular, keeping seasons mild and consistent. Its tilt produces a slow rhythm of warmth and coolness, a shifting of daylight that repeats predictably year after year. Earth's gravitational interactions with the Moon add another layer of gentle timing, tides rising and falling with a cadence that has shaped ecosystems for ages. Even the rotation of Earth, though rapid compared to planetary orbits, creates the dependable alternation of day and night, the simplest and most ancient rhythm known to life. Viewed from space, Earth's beauty is not only in its color or clouds, but in its pattern of movement. Storms swirl, currents drift, forests breathe with the seasons. Each of these processes unfolds at a pace compatible with calm. Jet streams curve across hemispheres, continents drift millimeters each year, mountains rise and erode over spans too long to grasp. The balance between change and duration gives Earth a kind of lived serenity, a reminder that motion at human scale can feel busy, but motion at planetary scale is slow and generous. Beyond Earth, the quiet of the inner worlds continues with Mars, the red planet. Mars rotates at almost the same rate as Earth, giving it familiar length days, but the thinness of its atmosphere turns its winds into whispers. Dust lifts lightly across plains and settles again without haste. The planet's dry riverbeds, ancient deltas, and sedimentary layers tell stories of water that once moved through its landscapes in steady flows. Though the water has since frozen or vanished, the shapes it left behind reveal the same patient transformations seen on other worlds. Over billions of years, sunlight, frost, and dust storms have carved Mars into a world of gentle slopes and soft, hazy horizons. Mars also contributes to the system's harmony through its orbit. More elliptical than Earth's, it brings the planet closer to and farther from the Sun in a way that moderates its seasons. Dust storms emerge during warmer periods, but even these vast storms, sometimes covering the entire globe, unfold with surprising calm. They rise gradually, drift across plains, and settle over weeks or months. The planet's thin air carries only faint pressure, so even strong winds feel less forceful than a breeze on Earth. This paradox, vast storms that barely push, adds to Mars's atmosphere of quiet contrast. Taken together, the inner planets reveal that calm can arise from differences as well as similarities. Mercury's silence, Venus's glow, Earth's rhythms, and Mars's soft winds are distinct expressions of the same underlying principle. Worlds moved into equilibrium by gravity, light, and time. Each planet maintains its own balance of motion and stillness, contributing to the solar system's peaceful structure. Where one world is fast, another is slow. Where one is hot, another cool. Where one is airless, another shrouded. These contrasts do not create discord. They form a spectrum of tranquility, a set of variations that enrich the overall harmony. The sunlight that touches the inner planets is part of this harmony. It arrives with intensity, yet its constancy creates a predictable environment for orbits and climates. Over billions of years, the sun has brightened gradually, but the changes are so slow that planetary systems adapt over vast spans of time. Sunlight warms surfaces, drives winds, and shapes atmospheres in ways that maintain long-term balance. On Earth, it fuels photosynthesis and stabilizes climate cycles. On Mars, it powers dust movements and seasonal frost. Even on Mercury, sunlight creates predictable temperature variations that define the planet's day-night rhythm. Consider the interplay of light and shadow across these worlds. Mercury's stark division between scorching day and frigid night becomes a kind of quiet heartbeat. Venus's thick clouds scatter sunlight into a uniform glow, producing soft illumination that never breaks suddenly into darkness. Earth's familiar alternation of day and night shapes human experience so deeply that it becomes a source of instinctive calm. Mars's dusty sky turns sunlight into a warm, muted hue that softens the landscape. The inner solar system is not only a place of motion, but a gallery of light, each world offering its own interpretation of the sun's radiance. At deeper scales, geology reinforces this serenity. Volcanic plains on Mercury lie unchanged for eons. Venus's surface, though reshaped in immense cycles, remains hidden beneath clouds that smooth every contour. Earth's continents shift gradually, their edges crumbling into sand and stone over long eras. Mars's dried riverbeds hold memories of slower climates, preserving the record of vanished lakes and ancient deltas. Time works softly in the inner solar system, carving landscapes gently even when conditions are extreme. Together, these worlds illustrate the guiding hypothesis that calm emerges from balance. Balance between gravity and speed, heat and cold, air and vacuum, change and duration. In the inner solar system, this balance is intimate, shaped by closeness to the sun. It is a realm where motion is swift but stable, where landscapes tell long stories, where sunlight defines life and stillness alike. As the mind drifts across these rocky shores and soft horizons, the sense of harmony deepens. Each inner world contributes its own chapter to the quiet biography of the solar system. And beyond them, farther from the sun's warm glow, the outer planets wait, vast, slow, and serene in a different way. The journey will continue, but the calm established here lingers, like a soft echo carried forward through the night. Farther from the sun, where light softens into a pale golden wash, the giant worlds drift in spacious arcs. Their presence feels different from the rocky planets, broader, slower, more enveloping. They are not solid surfaces, but vast atmospheres layered like gentle fabrics, each one moving in patterns that are ancient, persistent, and surprisingly calm when viewed across the immense scales of time that govern them. Entering this region of the solar system feels like stepping into a deeper room of the cosmic house, one where the ceilings are higher and the air moves with slow, continuous tides. Jupiter is the first of these giants, a world so large that it gathers much of the mass left over from the sun's formation. Its gravity creates a quiet sphere of influence that shepherds asteroids, shapes resonances, and stabilizes the architecture of the solar system in ways both subtle and profound. From a distance, Jupiter's striped bands appear restless, but closer study reveals long-term structures that drift with deliberate slowness. These colored belts and zones, alternating paths of rising and falling gas, circle the planet in patterns that have endured for ages. Though winds on Jupiter can reach tremendous speeds, the scale is so vast that the overall effect becomes serene, a reminder that magnitude can render even turbulence into harmony. The Great Red Spot exemplifies this paradox. A storm large enough to swallow Earth, it has persisted for centuries, revolving quietly within Jupiter's southern hemisphere. Its changes are gradual, slight shifts in color, small contractions, gentle drifts of position. Observatories track these evolutions across years, watching as the storm expresses the planet's deep rhythms. Despite its size, the Great Red Spot embodies patience. Its longevity speaks not of violence, but of stability, sustained by the planet's rotation and heat. When seen in time-lapse, its swirling edges resemble a slow-turning whirlpool, more meditative than chaotic. Jupiter's calm extends beyond its atmosphere into the realm of its many moons. Over 80 of them circle the giant planet, from tiny fragments to world-sized spheres. Their orbits form a complex but stable system, each path influenced by the gravity of others. Among them, The four largest, Io, Europa, Ganymede, and Callisto, glimmer like lanterns in the Jovian night. They orbit in quiet harmony, maintaining patterns that repeat with the precision of clockwork. Io's volcanic eruptions, Europa's icy crust, Ganymede's magnetic field, and Callisto's ancient surface each reflect a different aspect of the balance that shapes the outer solar system. Europa, with its smooth ice shell, offers an especially calming image. Its surface is crisscrossed with faint lines, the marks of shifting plates floating atop a hidden ocean. Scientists believe that this subsurface sea is warmed by tidal interactions, gentle flexing driven by Jupiter's gravity. This rhythmic stretching and relaxing keeps the ocean liquid beneath kilometers of ice. In this interplay of motion and stillness, Europa becomes a symbol of equilibrium, a quiet world sustained by forces that operate steadily and silently in the dark. Beyond Jupiter drifts Saturn, a planet associated with elegance for as long as telescopes have revealed its rings. These rings, made of countless icy particles, orbit in thin, delicate bands sculpted by gravity. While popular imagination often portrays them as solid structures, they are in fact immense fields of tiny objects, each following its own orbit with precision. Up close, the rings might seem alive with motion. From afar, they form a perfectly smooth halo. This merging of multiplicity into unity is one of the solar system's most serene sights. The ring's structure is maintained by shepherd moons, small bodies whose gravitational nudges keep the particles aligned. Their influence is gentle, subtle, and persistent, producing patterns like braids, spirals, and waves that evolve over years and decades. Saturn's atmosphere, like Jupiter's, is layered and dynamic, but with its own character: softer hues, slower storms, and a calm beauty shaped by distance from the sun. The planet's north pole hosts a hexagonal pattern of winds, an enduring shape that has puzzled and fascinated scientists for decades. Its edges are straight, its angles sharp, yet the entire shape rotates smoothly with the planet beneath. This enormous geometric storm is another example of how, on giant worlds, motion settles into forms that feel almost sculptural rather than chaotic. The hexagon is not a sudden burst of weather, but a long-standing resonance in atmospheric flows, a reminder that even turbulence seeks structure. Farther still lies Uranus, a pale world tilted dramatically on its side. This unusual orientation, likely the result of an ancient collision, gives Uranus seasons more extreme than any other planet. Yet despite this peculiarity, the planet remains one of the most tranquil in appearance. Its atmosphere is composed mostly of hydrogen, helium, and methane, which give it a soft blue tint. Early images showed a featureless sphere, calm and unbroken. More recent observations have revealed faint storms and cloud bands, but these features appear and drift with the quiet grace of patterns forming on a still pond. The planet's rings, though faint, add to its gentle character, circling at angles that reflect its unusual rotation. Uranus's calm is also rooted in its distance. Sunlight here arrives weakly, providing only a fraction of the warmth felt by Jupiter and Saturn. With so little energy driving atmospheric motion, the planet's weather evolves slowly. Winds blow, but they shape clouds that appear and fade like whispers. The cold, serene environment reinforces the idea that calm can emerge from simplicity, that even with vast size and deep atmosphere, a world can settle into understated rhythms. Neptune, the outermost of the giant planets, is more active than Uranus, yet it too conveys a sense of deep peacefulness. Its vivid blue color comes from methane absorbing red light, leaving the planet bathed in cool tones that evoke a quiet ocean. Winds on Neptune can reach extraordinary speeds, yet the overall appearance remains smooth because the features evolve on such large scales. Storms form and dissipate without urgency. They drift across the planet's face, shaped by internal heat rather than sunlight. This internal warmth, slowly radiating into space, powers patterns that endure softly across decades. One of Neptune's most harmonious elements is Triton, its largest moon. Triton orbits in a direction opposite the planet's rotation, a rare and intriguing arrangement that suggests it was captured long ago from the Kuiper Belt. Despite this unusual history, Triton now follows a stable path, contributing a sense of quiet companionship to Neptune's system. Its surface, shaped by nitrogen ice, reflects light like frosted glass. Faint geysers rise and fall, driven by seasonal warming, releasing plumes that drift gently before settling back to the ground. In this behavior, Triton mirrors the equilibrium seen across the giant worlds, processes that unfold slowly, predictably, and peacefully. The outer giants are bound not only by their own gravity, but also by their role in maintaining the solar system's wider balance. They shepherd comets, influence asteroid belts, and stabilize the orbits of smaller bodies. Their large masses absorb or deflect objects that might otherwise disrupt the inner system. In this sense, they act as guardians, massive, slow-moving presences whose gravitational fields extend outward like protective shields. Their calm does not come solely from their appearance, but from their function in preserving the harmony of the entire system. Time plays a crucial role in shaping the serenity of these distant worlds. The giant planets formed early and have remained relatively unchanged in their basic structures. Their atmospheres mix slowly. Their orbits shift gradually. Their rings evolve over long spans. Even their storms, though immense, are governed by patterns that repeat and stabilize over decades or centuries. This temporal scale encourages a sense of perspective, revealing that what seems dramatic on human terms becomes tranquil when stretched across astronomical ages. Light, too, contributes to the calm of the outer system. Here, the sun is a distant ember. Its rays travel farther, spreading wider and thinning into a soft glow. Daylight on Uranus or Neptune resembles twilight on Earth, a subdued illumination that quiets colors and softens contours. This gentle lighting reduces the visual contrast that might otherwise make storms or features appear dramatic. Everything blends into gradients, creating visual harmony that mirrors the underlying physical equilibrium. Even the transition from the giant planets to the realm of small icy bodies at the system's edge underscores the theme of balance. The giants mark a shift from rocky surfaces to fluid atmospheres, from warmth to cold, from inner turbulence to outer stillness. Each planet expresses its place in the wider pattern, demonstrating that calm can arise in multiple forms, as a stable orbit, a slow spinning atmosphere, a faint ring system, or a moon drifting through the dim glow of distant sunlight. Together, these giants form a serene archway leading outward, where the solar system expands into deeper darkness. Their presence shapes not only the gravitational structure of the system, but the emotional landscape of the night sky. Even from Earth, their light is steady. Jupiter and Saturn rise in predictable patterns. Uranus and Neptune, though faint, follow paths that align with the quiet logic of the cosmos. Their reliability, their slow, majestic orbits, and their vast, layered atmospheres all reinforce the central idea that calm is born from balance. Balance between inner heat and outer cold, gas and gravity, motion and emptiness. As the mind drifts past these immense worlds, It carries with it a sense of spaciousness that mirrors their scale. The solar system feels larger now, yet not overwhelming. The giants offer reassurance in their slow, deliberate movements. They remind the observer that even the largest forces can express themselves softly. And beyond them, in the dim frontier where sunlight becomes sparse, another layer of calm awaits. Beyond the giant planets, and woven among them, lies a realm of moons, worlds that orbit worlds, smaller companions that add intimacy to the vast, sweeping architecture of the solar system. These moons vary widely in size, composition, and character. Some are larger than planets, others little more than stony fragments. Yet many of them express the same profound calm found elsewhere in the solar family. They turn steadily, rise and set in slow cycles, and follow orbits sculpted by gravity's patient hand. Among these smaller bodies, motion becomes more delicate, driven not by the sun alone, but by the gravitational embrace of their planetary hosts. And because their movements are quieter, their stories are filled with subtle rhythms, tidal pulses, repeating patterns, and gentle interactions that amplify the overarching theme of balance. The most iconic set of moons orbits Jupiter, each one contributing its own tone to the system's softly humming harmony. Io, with its restless volcanoes, may seem the least peaceful at first glance. But even its hyperactive surface follows a tight, predictable rhythm. Its volcanic outbursts repeat across cycles shaped by tidal flexing, the same gravitational stretching that warms Europa's hidden ocean and influences Ganymede's magnetic activity. The three moons engage in a steady resonance. Every time Io completes 2 orbits, Europa completes 1, and when Europa completes 2, Ganymede completes 1. These ratios create a repeating cadence that stabilizes their paths. Instead of chaos, the system becomes a cosmic metronome, steady, reliable, and soothing in its precision. Europa, in contrast to Io's fiery surface, conveys tranquility in almost every aspect. Its ice shell is smooth and bright, reflecting sunlight with a soft, powder blue glow. Cracks and ridges stretch across it like lines on frosted glass, hints of slow tectonic movements occurring over ages. Beneath the ice, an ocean lies in darkness, warmed by the rhythmic internal heating driven by Jupiter's gravity. This hidden sea may be deeper than Earth's oceans and utterly still in its vastness. Any movement within it, currents, tides, or convection, likely unfolds at a pace so slow it would be nearly imperceptible. Europa embodies the idea that calm can bloom even in worlds both alien and extreme. Its silence is not emptiness, but depth, a kind of quiet shaped by pressure, darkness, and slow flexing over unimaginable spans of time. Ganymede, the largest moon in the solar system, holds a different kind of calm. With its own magnetic field and layers of rock and ice, it drifts through space like a miniature planet. Its surface shows regions of ancient terrain, some worn nearly smooth, others lined with grooves created by slow shifts in its icy crust. Weathered by billions of years, these patterns read like pages from a geological journal written in a careful, steady hand. The moon's sheer scale adds to its sense of gentleness. Everything it does occurs slowly, moderated by its mass and distance from the sun. Even its rotation is locked into rhythm with its orbit, turning once for each journey around Jupiter so that the same face always looks inward. An arrangement that reinforces the theme of long-term equilibrium. Callisto completes this quartet, a dark and ancient world untouched by internal activity for billions of years. Its landscape is one of quiet endurance, craters softened by time, plains dusted with frost, shadows etched into ridges that have not shifted in ages. Callisto represents the far end of geological calm, a world that has reached a state of deep rest. Nothing churns beneath its surface, nothing renews its terrain. It is a record of the solar system's early years, preserved in stone, offering a reminder that change eventually yields to stillness. Yet even here, where transformation has slowed to a whisper, motion persists. Callisto circles Jupiter with gentle steadiness, completing its orbit like a soft closing of a loop, again and again, across epochs. The moons of Saturn add another layer to this gentle symphony. Titan, its largest moon, is wrapped in a thick orange haze that diffuses sunlight into a warm amber glow. Though its surface remains hidden beneath this atmospheric veil, probes have revealed lakes of methane and ethane, sculpted shorelines, and dunes shaped by winds that move with slow persistence. Titan's atmosphere is dense compared to its size, allowing for weather that unfolds in muted cycles. Raindrops fall not with intensity, but with patience, drifting through the heavy air before touching the cold ground. This slowness extends to everything on Titan: the movement of clouds, the shifting of seasons, the subtle variations in temperature. It is a world where time feels stretched, elongated by cold and distance, encouraging a sense of contemplative equilibrium. Nearby, Enceladus offers a contrasting expression of calm. Its icy surface gleams brilliantly against the blackness of space, and its south pole features geysers that release plumes of water vapor and ice crystals. While geysers might seem contrary to tranquility, on Enceladus they occur with rhythmic steadiness, controlled by tides generated from Saturn's gravity. These plumes rise gracefully, forming arcs that drift outward before falling back as frozen mist. Much like Europa, Enceladus harbors a subsurface ocean, warmed by internal flexing. The world's beauty lies not only in its motion, but in the constancy of that motion, a cycle that repeats with quiet reliability, mirroring the heartbeat of the system it belongs to. Smaller moons, too, contribute their own unique forms of serenity. Tethys, with its vast canyon slicing across its surface, has likely been geologically inactive for ages, leaving its terrain unchanged except for the slow accumulation of cosmic dust. Dione and Rhea are similarly calm, their surfaces bearing marks of ancient impacts, but showing little modern activity. Iapetus, a distant moon with one side dark and the other bright, rotates slowly enough that its days stretch on for Earth weeks. Its stark coloration creates a world of powerful contrast, yet the sharp boundary between light and dark has persisted through the ages, stabilized by its slow spin and gentle orbit. Even the small shepherd moons embedded in Saturn's rings move with grace. They circle the planet in patterns that keep ring particles aligned, preventing collisions and maintaining the thin, structured bands that give Saturn its iconic appearance. Their influence is subtle but necessary, the gravitational equivalent of quiet caretakers tending to a delicate system. Their motion, though tiny compared to the giants they orbit, reinforces the broader theme of calm emerging from interaction rather than isolation. Farther out, the moons of Uranus and Neptune continue the pattern of subtle, enduring rhythms. Miranda, one of Uranus's innermost moons, displays a patchwork of cliffs and ridges, evidence of ancient upheavals now long settled. Its unusual terrain tells of internal processes that once reshaped its surface, yet today Miranda appears serene, its orbit steady and its features unchanged. Ariel and Umbriel, two other Uranian moons, drift through space in near-perfect synchrony, their surfaces marked by slow erosion and faint coloration. Titania and Oberon, larger and more distant, Complete the set with landscapes that speak of time's gentle, sculpting hand. Neptune's system, though farther and dimmer, also embraces tranquility. Triton, the captured moon with a retrograde orbit, follows a path carefully stabilized by gravitational interactions. Its geysers, driven by nitrogen ice warming in the sparse sunlight, release plumes so delicate they arc gently before collapsing like feathers falling back to the ground. Nereid, another Neptunian moon, follows a wide, eccentric orbit that stretches and relaxes like a slow breath across centuries. Taken together, these moons form a tapestry of quiet worlds orbiting larger ones, each contributing to a shared rhythm that propagates outward through the solar system. Their tides, rotations, and orbits echo the guiding principle of cosmic calm derived from balance. Even moons with dynamic features, volcanoes on Io, geysers on Enceladus, shifting methane cycles on Titan, contribute to this calm because their motions occur within frameworks that remain consistent across vast spans of time. Nothing happens abruptly on a cosmic scale. Even when surfaces shift or atmospheres circulate, they do so under rules that gently guide and restrain them. The moons also serve as bridges between scales. They link the intimate, small bodies orbiting close to their hosts, with the grand, planets orbiting the sun. Their paths echo the orbits of larger worlds, creating nested patterns where motion at one level harmonizes with motion above and below. This fractal-like layering deepens the sense of interconnected tranquility. One can follow the orbit of a tiny moon around Saturn, then trace Saturn's orbit around the Sun, and discover that both arcs contribute to the same overarching harmony. In this intertwined network of movements, the solar system resembles a mobile suspended in darkness, every piece turning in coordination with the others. As the mind drifts across these smaller worlds, it becomes clear that calm does not require homogeneity. Diversity, when shaped by balance, enhances serenity rather than disturbing it. Smooth ice, rugged stone, thick atmosphere, thin air, subsurface oceans, frozen deserts, all coexist within a system that maintains coherence through gravity, time, and predictable motion. Each moon offers its own perspective on equilibrium, proving that tranquility in the solar system is not merely the absence of change, but the presence of rhythms that persist gently across ages. And beyond the giants and their companions, another population of small bodies waits. The asteroids and comets drifting between orbits, shaped by forces too faint to hurry them. Between the orbits of Mars and Jupiter lies a region often imagined as a chaotic maze of flying rocks, but the truth is far more serene. The asteroid belt, stretching like a faint ring of scattered embers, is spacious and quiet. Most of its objects are separated by hundreds of thousands of kilometers. If someone drifted through it, they might not see a single asteroid for days. The belt's calmness reflects the same equilibrium that shapes the rest of the solar system. Forces balanced over billions of years, each stone following its own slow path, influenced by the gravity of the sun and the gentle tug of the giants beyond. The asteroids themselves are varied in size and history. Some are large enough to be called dwarf planets, while others are no bigger than pebbles. Yet despite this diversity, they share a common rhythm. Their orbits are mostly stable, maintained by gravitational resonances that sculpt gaps and clusters within the belt. The most famous of these, known as Kirkwood gaps, are regions where Jupiter's influence nudges asteroids into new paths over long periods. These gaps form naturally, like patterns carved by a slow tide. Rather than creating disorder, Jupiter's presence organizes the belt, encouraging asteroids to settle into orbits that avoid long-term conflict. Ceres, the belt's largest member, is a world of gentle contrasts. Its surface shows smooth plains and bright spots of reflective salts, remnants of water ice that once rose from underground and settled again. These features tell a story of slow geological evolution. Even today, traces of subsurface brines may migrate gradually through its crust. The changes are subtle, measured across centuries rather than days. Ceres reflects the idea that small worlds, like large ones, can express calm through processes that unfold at patient tempos. Vesta, another major body in the belt, displays a more rugged terrain shaped by impacts billions of years ago. Yet even here, the violence of the past has faded into quiet forms. The vast crater at its south pole, once created by a collision of incredible force, has softened under the unchanging stillness of space. Dust has settled, ridges have smoothed, and Vesta continues to circle the sun in a stable orbit. Over immense spans, time transforms chaos into order, leaving behind a landscape that appears still and composed. Most of the asteroid belt is filled with objects smaller than Ceres or Vesta, but their collective behavior reinforces the system's harmony. Each fragment orbits the sun according to rules that change little from century to century. The slow drift of some asteroids, caused by the subtle push of sunlight, the Yarkovsky effect, adds a layer of nuance to their movements. But even this influence is gentle. Light itself becomes a sculptor, applying pressure so faint that its effects compound only over millions of years. Instead of disrupting the belt, this faint force produces patterns of movement that researchers can predict long in advance, further revealing the solar system's underlying balance. Beyond the traditional belt lies a region of small bodies known as the Trojans, clusters of asteroids that share Jupiter's orbit, but remain safely ahead of or behind the planet. They occupy stable gravitational niches, called Lagrange points, where the pull of the Sun and Jupiter combine to form pockets of equilibrium. These asteroids drift along with Jupiter like quiet companions, locked into their positions by the same harmonizing principles that organize moons and rings elsewhere. For billions of years, the Trojans have maintained their places with minimal disturbance, demonstrating how balance can emerge naturally from the interplay of gravitational forces. Farther out, between the orbits of the giant planets, small bodies continue to drift in zones where their paths remain steady and predictable. The centaurs, icy, comet-like objects that wander among the giants, follow orbits that evolve slowly under gravitational influences. Though some eventually shift inward and become comets, many remain in their gentle loops for ages before any significant change. Their transformations, when they happen, unfold across spans of time so large that they do not disrupt the peaceful architecture of the system. The concept of resonance plays a major role in shaping how these small bodies behave. When an asteroid or icy fragment enters an orbit that aligns with the period of a giant planet, such as completing 2 orbits for every one of the planets, gravitational interactions accumulate gently over time. These resonances can either stabilize or gradually shift the orbit, but they do so in ways that preserve order. This structure, repeated across distances, becomes a quiet lattice of gravitational influence. Rather than chaos, the result is an organized pattern of motion that scientists can trace through models extending far into the future. Comets add another layer of quiet complexity to the solar system. Their elongated orbits carry them from the cold outer reaches inward toward the sun, and then back again, like slow-moving visitors that trace long loops through space. From up close, a comet's approach might seem dramatic, releasing gas and dust that form glowing tails. Yet even this apparent flurry of activity is governed by predictable cycles. When warmed by sunlight, ices on the comet's surface sublimate into gentle jets. These jets are not violent blasts, but steady streams shaped by temperature gradients and internal structure. Over time, these processes reshape the comet slowly, altering its path with slight nudges that accumulate patiently. The orbits of comets reveal much about the solar system's broader equilibrium. Some originate in the Kuiper Belt, a region just beyond Neptune filled with icy bodies that orbit the Sun in a stable, expansive field. Others come from the distant Oort cloud, a spherical shell of frozen fragments that extends far beyond the planets. The vast majority of these objects remain undisturbed for billions of years, held in place by the faint but persistent pull of the Sun. Only occasionally do gravitational nudges from passing stars or the gentle tide of the galaxy shift an object inward. When this happens, the journey takes thousands or even millions of years, unfolding with a slowness that keeps the solar system's calm intact. Asteroids and comets can seem isolated, but they form an integral part of the solar system's harmony. Their presence adds texture to the vast spaces between planets, a quiet commentary on the system's structure. They help distribute material, carry ancient clues about formation, and occasionally deliver ingredients to planets, as comets likely did for early Earth. This subtle role echoes the central hypothesis. Calm arises from balance, not stagnation. Even tiny objects contribute to the equilibrium by adjusting their paths and influencing others in ways so gradual they blend seamlessly into the background of cosmic motion. One of the most beautiful aspects of the asteroid and comet populations is how gently their collective behavior shifts over time. The arrangement of the belt, the distribution of Trojans, the long arcs of comets, all evolve across billions of years, shaped by repeating cycles and small nudges. Scientists studying these populations can trace these patterns backward to the solar system's youth and forward into its distant future. Their predictability reinforces the sense that the solar system is not a place of random scattering, but a finely tuned environment where even minor members follow quiet, orderly rules. This quiet order becomes even more apparent when imagining a slow journey through these regions. A spacecraft traveling between Mars and Jupiter would glide for months without encountering anything large. The occasional asteroid glimpsed in the distance would drift along its path, unaware of the observer. Farther out, icy fragments would shimmer faintly under distant sunlight, each one on its own tranquil voyage through space. Comets passing inward would do so with measured arcs, their tails forming slowly as sunlight awakens their surfaces. Nothing would appear rushed, nothing abrupt, only the steady unfolding of cycles that have guided countless bodies for billions of years. As the mind settles deeper into this region of softened motion and wide emptiness, the subtle link between these small objects and the system's large-scale piece becomes clear. Their paths, though individually small, form a network that absorbs and distributes gravitational influences gently. They reveal that tranquility can emerge not only from massive worlds with broad atmospheres, but also from tiny fragments drifting silently in the dark. It is the collective pattern that creates harmony, the sum of countless quiet movements that shape the solar system's identity. Beyond the asteroid belt and the wandering centaurs lies the next great frontier of calm, the Kuiper Belt, where sunlight becomes a faint glow and worlds drift even more slowly. There, at the edge of the known planets, the theme of balance deepens into a realm of soft shadows and frozen bodies waiting in the quiet. Sunlight, the quiet force threading the entire solar system together, becomes gentler the farther it travels from its source. Near the Sun, It is bright and insistent, shaping the climates and cycles of the inner planets. But as it drifts outward, past the orbits of Mars and Jupiter, it thins into a soft, diffuse glow. By the time it reaches the realm beyond Saturn, its warmth is delicate, more like the memory of light than the light itself. And yet, even in this faintness, sunlight remains the quiet regulator of the solar system. It sets the tempo, defines the seasons, and provides the subtle energy that guides the behavior of worlds, small and large. Light behaves simply. It travels outward at the same speed everywhere, unfurling like a growing sphere. But its influence is felt differently by different worlds. On Earth, sunlight creates day and night, drives winds, warms oceans, and supports life. On Mars, its thinner but predictable warmth shapes seasonal frost and dust storms. On the giant planets, sunlight forms upper cloud layers and colors atmospheric bands. And in remote regions like the Kuiper Belt, it reaches with such softness that it shapes only the most delicate processes: slow sublimation of ices, faint chemical reactions on distant surfaces, and a kind of twilight illumination stretching across vast, frozen plains. This gradient of sunlight, from strong to moderate to faint, creates a layered harmony across the solar system. Each region responds in a unique way, contributing to the system's overall balance. There is no single rhythm imposed from the center. Instead, every world interprets sunlight according to its distance, composition, and history. This diversity of responses deepens the tranquility of the solar system by showing that equilibrium is not uniform but adaptive. Even dim light, when consistent, becomes a stabilizing presence. Closer to the sun, light warms Mercury's days to extremes before the planet returns to cold night. Because there is no air to hold its warmth, the sunlight's influence is sharp and clean, creating a stark rhythm as Mercury rotates slowly through exposure and shadow. Venus, with its thick atmosphere, traps sunlight so effectively that its surface becomes an oven of heat, a powerful demonstration of how the same energy can shape environments differently depending on local conditions. Yet even here, the thick clouds disperse sunlight into a constant amber haze, smoothing the day-night cycle into a slow, steady gradient. Earth's dance with sunlight is more subtle, tied to the tilt of its axis. The angle of sunlight changes as Earth circles the sun, creating seasons in a gentle annual loop. This rhythm shapes ecosystems, migrations, weather patterns, and the psychologies of living things. For humans, the lengthening and shortening of days have inspired countless cultural practices, marking times of planting, harvest, rest, and renewal. The predictability of these cycles contributes to the sense of calm that sunlight imparts, an assurance that warmth and light will return after darkness. That change will follow patterns rather than chaos. Mars experiences sunlight at roughly half the intensity felt on Earth, creating seasons that are similar in pattern but softer in energy. Frost forms in the cold months, then sublimates back into the atmosphere as light returns. Dust, warmed by the sun, rises into the air and drifts across plains in slow-moving hazes. Even the planet's vast dust storms, which can envelop the entire globe, begin gradually, as sunlight warms one hemisphere slightly more than the other. These storms are vast in scale, but not violent in motion. They build slowly, endure patiently, and fade with equal delicacy. Farther out, sunlight loses its sharp edges. At Jupiter's orbit, it is only a quarter as strong as on Earth. This reduced brightness does not lessen the planet's visual beauty, but softens it. Light interacts with ammonia crystals and water vapor in Jupiter's clouds, creating pastel bands rather than vivid hues. The shadows of its moons glide over its surface in slow, smooth sweeps, visible only because the sun still provides enough glow to cast them. These transits, tiny eclipses carried out by small worlds, reinforce the gentle choreography that binds the system. Each shadow passes quietly, leaving no trace, moving on a schedule repeated over and over. Saturn receives even less sunlight, and the faint glow accentuates the planet's pale rings. The icy particles reflect light with a softness that gives the rings their gentle, ethereal quality. In the dim illumination, the rings become more transparent, more ghost-like, their billions of pieces moving in unison. Sunlight within this part of the solar system no longer energizes weather systems robustly. Instead, it paints surfaces and atmospheres with muted tones that shift slowly with the seasons. On Uranus and Neptune, the sun is little more than a bright star. Its rays still warm their upper atmospheres, but with a gentleness that shapes cloud patterns loosely rather than forcefully. Methane in their atmospheres absorbs red light, leaving each planet bathed in calming shades of blue. These worlds turn slowly, their seasons unfolding across decades. Sunlight here is not a dynamic force, but a quiet companion. Beyond Neptune lies the Kuiper Belt, where sunlight becomes a subdued whisper. It reaches bodies like Pluto, Eris, Makemake, and Haumea with such softness that it cannot melt surface ices quickly or reshape landscapes on short timescales. Instead, it works over centuries, driving slow cycle changes, nitrogen frost migrating from pole to pole, methane snow settling in faint layers, volatile ices sublimating gently during long summers and returning in long winters. A single season on Pluto lasts longer than many human lives, turning sunlight into a kind of slow breath that expands and contracts across the world's surface. Even at this distance, light carries information. It reveals textures and colors on faraway surfaces, hinting at the composition of ices and the subtle interactions that sustain faint atmospheres. When spacecraft like New Horizons pass through these regions, their cameras rely not on floodlights or active illumination, but on the sun itself. Its rays, even in their faintness, are sufficient to expose landscapes never before seen. This ability of sunlight to remain relevant across such enormous distances highlights its role as the solar system's quiet architect. It never forces, never stops, never hesitates. It simply travels outward, evenly and impartially. At the very limits of the sun's reach lies the heliopause, the boundary where the solar wind slows to a halt against the interstellar medium. Here, sunlight is nearly imperceptible, reduced to a dim glow. But even this soft light maintains a presence, carried by photons that have traveled billions of kilometers without hurry or decay. Beyond this boundary, the sun becomes just one star among many, its influence blending into the larger backdrop of the galaxy. Sunlight shapes more than planetary surfaces. It shapes orbits themselves. Over long timescales, the exchange between solar radiation and small bodies produces gentle shifts in their paths. For asteroids, sunlight can warm one side more than the other, creating a slow rotation or drift. For comets, it triggers the release of ice and dust that subtly alters their trajectories. These processes are not disruptive. They are quiet adjustments, aligning bodies with regions of stability, preventing collisions, and smoothing the distribution of fragments. Light, in this sense, becomes a sculptor, one that works with infinite patience. The solar wind, though distinct from sunlight, reinforces this equilibrium. It is a stream of charged particles moving outward, forming the heliosphere. While invisible, it shapes the space environment around planets and small bodies, creating boundaries that respond to both the sun's activity and the pressures of interstellar space. Even here, at this vast scale, the balance between outward flow and external resistance maintains a stable, gentle boundary around the solar system. Culturally, sunlight has always been tied to the rhythm of sleep and wakefulness, to the emotional cycles of life. Its presence brings warmth, and its absence brings rest. The solar system mirrors this relationship on a cosmic scale. Where sunlight is strong, worlds are active. Where it is faint, calm deepens. Yet in every region, the sun provides consistency, a slow, predictable diminishing of light that shapes the environments of all the worlds circling it. This soft gradient of warmth and illumination reinforces the central idea that calm does not require uniformity. Instead, it arises from the predictability of gradual change. Light fades with distance, but it never vanishes abruptly. Temperature decreases, but over such scales that equilibrium remains undisturbed. Atmospheric responses shift, but they do so in ways that continue long rhythms rather than introduce sudden transformation. As the imagination drifts outward with these thinning rays, the solar system reveals itself not as a strict hierarchy of warm and cold, active and quiet, but as a gradient, an unbroken spectrum of equilibrium guided by sunlight. This gradient will continue into the next chapter, where the relationship between light and landscape, time and surface becomes even more apparent in the textures that shape the outer worlds. Across the wide expanse of the solar system, each world wears its own set of textures, patterns etched by time, shaped by sunlight, sculpted by gravity, and softened by the long, slow rhythms that govern the cosmos. When viewed in isolation, these textures can appear dramatic, towering dunes, sprawling ice fields, swirling storms, and fractured plains. But when seen on the scale of planetary time, they reveal a deeper calm. Every feature, whether formed through wind, ice, frost, or internal heat, evolves with patience. Landscapes become living testaments to the way motion and emptiness come together to create gentle, enduring forms. Mars offers one of the clearest examples of this interplay between texture and time. Its surface is covered by vast dunes, shaped by thin winds that slide grains of sand along the ground in tiny hops. These movements, called saltation, occur quietly. A single grain might travel only a short distance in a gust, but over millions of years, the dunes migrate with slow grace across plains and craters. Photographs from orbit reveal delicate ripple patterns on dunes, fine parallel lines that trace the whisper of wind across the Martian desert. These ripples shift occasionally, responding to seasonal breezes, yet the dunes themselves hold their shapes, like gently frozen waves. Elsewhere on Mars, canyons speak with equal softness. Valles Marineris, a chasm stretching thousands of kilometers, looks at first glance like a wound carved by violence. But the forces that shaped it, tectonic tension, erosion, landslides, acted over ages. The canyon deepened gradually, widened slowly, and stabilized into a quiet monument to the slow flexing of Mars's crust. Its cliffs, though rugged, stand in silence beneath a thin atmosphere where sound barely carries. Dust drifts down their sides in faint streaks, leaving traces of subtle shifts that continue today. What appears sharp and severe from afar becomes gentle when framed by the long view of time. On Earth, textures change more quickly due to wind, water, and life. Rivers carve valleys, glaciers sculpt mountains, and waves reshape coastlines. Yet even here, the overall tempo is slow enough to seem serene from a cosmic vantage point. Mountains rise through the slow collision of plates, and they erode grain by grain. Deserts expand and contract with climate cycles. Forests grow and recede with shifts in temperature and rain. Though humans experience these changes within lifetimes, the planet itself experiences them as part of a long, continuous unfolding. Another example of balance in motion. Farther out, the gas giants exhibit textures of a different sort. Jupiter's atmosphere contains swirling bands and storms, but their forms evolve slowly when viewed over years and decades. Bands shift position with gradual flows, and storms merge or fade at a pace that reveals the stability of the system. The Great Red Spot, though shrinking, retains its oval shape, spinning with the same deliberate rotation that has defined it for centuries. The layers of Jupiter's atmosphere create zones where temperature and composition interact to produce structures that remain coherent across vast time frames. Each stripe, each eddy, and each color trace is a visible expression of fluid dynamics operating in equilibrium. Saturn's banded atmosphere provides a similar case, though softer in tone. Its creamy hues blend seamlessly, shaped by ammonia clouds and subtle differences in composition. At the planet's north pole, the hexagon, a six-sided jet stream, rotates with uncanny precision. The angles remain sharp, the edges straight, and the entire structure moves as though carved from air rather than formed by it. This hexagon hints at deeper stability within Saturn's atmospheric layers, a resonance that persists despite seasonal changes and internal flows. It is a reminder that the universe often arranges itself into repeating structures when forces balance just right. Texture also appears in Saturn's rings, where waves ripple through sheets of icy particles. These waves, called spiral density waves and bending waves, are triggered by gravitational influences from nearby moons. When a moon nudges the ring, it creates a pattern that travels outward, like a vibration through a harp string. These waves can persist for years, moving slowly across the rings and increasing or decreasing in amplitude as they go. The result is a dynamic but gentle motion, a system of patterns shaped by repeated interactions rather than sudden events. To watch these waves unfold is to observe harmony in its purest form, interactions that propagate smoothly through a medium composed of countless small parts. Uranus and Neptune, though faint and remote, also display textures in their atmospheres. Uranus's clouds are subtle and often difficult to detect, but when illuminated at the right angles, they reveal faint streaks and bands. These patterns shift with the planet's slow rotation and respond softly to changes in solar illumination. Neptune, with its deeper blue tones, supports storms that drift across its face, forming dark spots that come and go across decades. These storms are driven by internal heat rather than sunlight, which means they evolve according to rhythms that are independent of the seasons. Even so, their behavior remains calm when considered on planetary timescales. They arc across the atmosphere in slow, predictable curves before dissolving. Icy moons add another dimension to this gallery of planetary textures. On Europa, the ice crust is crisscrossed with long, curving lines, fractures created by tidal forces that stretch and compress the surface. These fractures migrate outward over time, leaving older ones behind like faded scars. Some regions display complex patterns resembling braids or lattices, formed by slow interactions between ice plates. In a sense, Europa's texture is a diary of stress and relaxation, written in the language of cracks and ridges rather than erosion or volcanic flow. Enceladus shows a more active version of this pattern. Its south polar region, marked by fissures called tiger stripes, releases plumes of water vapor and ice crystals. These plumes deposit fresh material on the moon's surface, creating smooth areas that contrast with older, cratered regions. Over time, geyser cycles shape the terrain gently, building layers of frost that accumulate like snowfall. Even this dynamic process unfolds slowly, governed by heat generated from tidal flexing rather than abrupt internal pressure. The moon's surface becomes a record of calm repetition, jets rising and falling, ice settling, and fractures spreading quietly over millennia. On Titan, Saturn's largest moon, textures arise from an entirely different set of processes. Lakes and seas of liquid methane fill depressions in the landscape, their surfaces smooth and reflective. Dunes stretch for hundreds of kilometers across equatorial regions, shaped by winds that blow with the softness of a deep, cold atmosphere. These dunes, composed of hydrocarbon grains, shift with seasonal breezes that move slowly due to Titan's dense air and gentle temperature gradients. Patterns etched on Titan's surface are created by the patient cycle of evaporation, condensation, and rainfall of methane and ethane, a slow liquid dance that mirrors Earth's water cycle, but at a far more relaxed pace. Pluto, though distant, offers one of the most striking examples of texture shaped by subtle forces. Its surface is a mixture of nitrogen, methane, and carbon monoxide ice, arranged in terrains that look almost surreal. The heart-shaped plain, known as Sputnik Planitia, displays polygonal cells, likely caused by convection within a thick layer of nitrogen ice. These polygons shift upward at their centers and sink at their edges in cycles spanning hundreds of thousands of years. The process is so gradual that it would be invisible to any observer with a short lifespan. Nearby, dark ridges and troughs stretch across the landscape, shaped by winds and seasonal freezing and thawing. Pluto's surface becomes a quiet interplay of deep cold and faint sunlight, producing one of the most peaceful landscapes in the solar system. Even the Kuiper Belt objects beyond Pluto show hints of texture. Eris, larger than Pluto, reflects sunlight with a brightness that suggests a surface coated in fresh ice. Makemake, with its reddish hue, shows patches of methane frost. Haumea, elongated by rapid rotation, possesses rings and icy facets that reflect light unevenly. Each of these distant worlds transforms faint sunlight and slow internal processes into textures that evolve across immense spans of time. Their surfaces remain stable not because they lack forces, but because those forces operate at such subtle levels that change becomes a whisper rather than a shout. When considering all of these textures, dunes on Mars, bands on Jupiter, ridges on Europa, dunes on Titan, polygons on Pluto, a unifying theme emerges. Calm is not emptiness. It is pattern, formed slowly. Texture is the visible record of long rhythms, like music stretched across centuries. Each world holds its own tempo, shaped by sunlight, gravity, and internal heat. These tempos differ, yet they combine into a symphony of slow transformation that reinforces the central hypothesis. Balance in motion creates serenity. The mind, drifting among these landscapes, feels the scale of time expand. Human concerns shrink in comparison to dunes migrating over millennia or storms completing century-long cycles. The surface of each world becomes a meditation on patience, a reminder that change can be gentle even when the forces involved are immense. And beyond these textured surfaces lies the next frontier, the outermost reaches of the solar system, where the dim glow of the sun shapes worlds of ice and shadow. Beyond Neptune's broad and stately orbit lies a region where sunlight fades into a faint glimmer, and worlds drift so slowly that their journeys barely register in human terms. This is the Kuiper Belt, a vast, icy frontier stretching millions of kilometers outward. It is here that the solar system's calm deepens into something almost contemplative. The pace slows, light dims, time seems to stretch. Worlds move with a quiet steadiness that reflects a balance older and wider than anything found closer to the sun. The Kuiper Belt is home to countless icy bodies, each one a remnant of the solar system's early days. These objects are not leftovers in a disorderly sense, but preserved pieces, stored in the cold like ancient pages kept in a silent archive. Their surfaces, chilled to temperatures far below anything known on Earth, change only gradually. Frost migrates with the long seasons. Ices sublimate and recondense over centuries, and sunlight sculpts slow chemistry across frozen plains. Even impacts, so common in the chaotic youth of the solar system, occur here infrequently due to the sheer distances separating objects. Pluto is the most famous resident of this region, its demotion from planetary status overshadowing the far richer truth of its nature. It is a world of subtle color and texture, with soft pinks, whites, and charcoal hues blending across valleys, mountains, and plains. The heart-shaped area known as Tombaugh Regio is not simply a charming shape, but a dynamic field of nitrogen ice. The left half of this region, Sputnik Planitia, behaves like a deep, frozen sea whose surface moves slowly through convection. Warmth from Pluto's interior, faint but persistent, causes ice to rise and fall in cycles lasting hundreds of thousands of years. The polygons on the surface shift gently as this frozen sea circulates, creating a slow, tranquil rhythm hidden beneath an appearance of stillness. Pluto's atmosphere, though thin, also changes across its long orbit. When the dwarf planet approaches the Sun, its surface ices warm slightly, releasing nitrogen that forms a tenuous atmosphere. As Pluto moves away again, sunlight weakens, and the gases freeze back onto the surface, coating it with thin frosts. These cycles unfold across decades, reflecting the delicate interplay of light and cold. Even the faint haze layers in Pluto's sky, dozens of them, stacked like sheets of transparent silk, are shaped by calm chemical reactions, driven by sunlight interacting with methane. The haze rises, settles, and disperses with gentle predictability. Charon, Pluto's largest moon, shares this calm, locked in tidal embrace. Pluto and Charon always show the same face to each other. Their orbit, a gentle dance around a shared center of mass, repeats with unwavering precision. Charon's surface, covered with water ice and marked by a broad hemisphere of darker material, shows evidence of ancient tectonic activity that has long since quieted. Deep canyons and smooth plains bear witness to processes that once shaped the moon, but have now settled into stillness. The connection between Pluto and Charon, two worlds orbiting each other with measured steadiness, reinforces the theme of equilibrium, a harmony found even in binary systems at the edges of sunlight. Other dwarf planets inhabit the Kuiper Belt with their own quiet personalities. Eris, slightly larger than Pluto, reflects sunlight with remarkable brilliance due to its bright methane frost. It orbits the Sun in a long, elongated path that takes centuries to complete. At its farthest point, Eris receives so little light that its surface temperature drops to extremes, causing ices to settle into a state of near-perfect stillness. Only when it approaches its closest point to the Sun might its methane frost shift and release faint gases. These changes unfold at a pace so slow that even a millennium seems short by comparison. Makemake, with its reddish hues, drifts in an orbit similar in distance to Pluto's. Its surface shows patches of methane frost and darker regions that reflect subtle seasonal changes. Haumea, elongated by rapid rotation, possesses rings and a surface of crystalline water ice that glints even under weak sunlight. Despite their differences, all these worlds share the same overarching mood, a serene stability shaped by distance, cold, and slow motion. Between these larger bodies are countless minor Kuiper belt objects, ranging from small icy fragments to multi-kilometer spheres. Their surfaces are often marked only by faint impacts or slow chemical changes triggered by cosmic rays and sparse photons. Their orbits, though varied, tend to fall into stable patterns influenced by Neptune's gravity. Many Kuiper belt objects are locked in resonances with Neptune, their orbital periods forming ratios like 2:3 or 1:2, ensuring that even as they drift through vast distances, they never come too near the giant planet. These resonances are soft guardians, maintaining order through repeated, gentle gravitational nudges. Instead of chaos, the Kuiper belt exhibits a quiet architecture arranged by subtle interplay. The concept of resonance becomes particularly fascinating when tracing the orbits of objects called Plutinos, Kuiper belt bodies that share Pluto's 2.3 resonance with Neptune. They complete 2 orbits for every 3 of Neptune's. Despite crossing Neptune's path in projection, they never collide with the planet, because the resonance locks their movements into a pattern that avoids close encounters. This elegant orbital choreography highlights the solar system's capacity for self-organizing calm. Even at its outer edges, gravitational harmony governs motion. But the Kuiper belt's tranquility is not just a product of orbital mechanics. Its remoteness from strong light and heat plays an equally important role. Sunlight here is dim enough that chemical reactions occur at a glacial pace, preserving ancient ices. The lack of atmospheric weather on most objects means surfaces erode slowly, leaving craters sharp and landscapes unchanged for epochs. In this environment, time becomes a gentle sculptor. Features persist through eras, allowing scientists to study the solar system's early conditions with exceptional clarity. Imagine drifting through this region as a distant observer. The sun would appear as a bright star, far away yet unmistakably present. Light would reflect off distant bodies with cool tones, muted blues, rosy pinks, pale grays, colors softened by frost and methane ice. Shadows would seem longer, cast at angles that hint at the sun's distance. The silence would feel deeper here, almost absolute, because the emptiness between objects expands so much that even the faintest disturbances dissipate. Occasionally, a cometary body might wander inward from this region, its icy surface beginning to warm slightly as it approaches the inner system. But the journey would be slow, taking centuries to bring the comet into the realm of stronger sunlight. And even as its surface begins to release gases, the process would unfold with a predictability shaped by composition and orbit. Nothing here happens hurriedly. Beyond the Kuiper belt lies a transitional zone sometimes called the scattered disk, where objects have been shepherded into more elongated orbits by gravitational encounters. These bodies travel far from the sun before looping back, their trajectories extended into long, slow arcs. Their movements, though more dramatic in shape, are still balanced by the faint pull of the sun and occasional nudges from the outer giants. Each orbit reflects the same principle seen elsewhere: motion that finds stability through repeated interaction. The Kuiper belt is not simply a distant region. It is a reminder of how the solar system operates at its edges. It shows that calm does not fade with distance. Instead, it deepens. Light softens. Motion slows. Processes become subtle. Even the cold, which might seem harsh, becomes a stabilizing factor, preserving structures that would change quickly in warmer environments. Far from being a forgotten frontier, the Kuiper Belt is a quiet sanctuary of cosmic memory, a place where the solar system's early rhythms still echo. As the journey continues outward, beyond the dwarf planets and icy fragments, sunlight grows even weaker, and the boundary of the sun's influence begins to blur into the wider galaxy. There, in the distant heliosphere, a different form of calm emerges, one shaped not only by light, but by the meeting of solar wind and interstellar space. Far beyond the orbits of the planets, where the sun's light softens into a pale memory, another kind of boundary begins to take shape. A vast frontier where the solar wind, streaming outward from the sun, begins to slow and mingle with the thin material that fills the space between stars. This immense region is called the heliosphere, a protective bubble formed by the sun's influence. It stretches for billions of kilometers in every direction, its shape molded by delicate balances between outward flow and inward pressure. Here, the calm of the solar system reaches a new scale, expanding into a quietness that blends into the soft tides of the galaxy. The solar wind originates in the sun's outer atmosphere, where charged particles escape into space at high speeds. Though invisible, it fills the solar system with a faint, continuous breeze. Closer to the sun, this flow is strong enough to shape the behavior of magnetic fields around planets and small bodies. But as it travels outward, its strength diminishes. Like a river diffusing into a vast ocean, the wind eventually becomes thin enough that the pressure of interstellar space pushes back. This meeting creates a boundary called the termination shock, where the solar wind slows abruptly. Yet even here, the process is not violent. Instead, it resembles a great exhalation reaching its gentle limit. Beyond the termination shock lies the heliosheath, a region where the solar wind continues to weaken as it mixes with interstellar particles. This zone is wide and diffuse, filled with motions that are soft and slow. The flows do not collide sharply. They merge, drift, and transform, guided by the interplay of magnetic fields. The heliosheath is a transitional space, a cosmic twilight where neither the solar system nor the galaxy fully dominates. It is here that Voyager 1 and Voyager 2, launched decades ago, now travel, tiny emissaries drifting through a place where boundaries are stretched thin and light becomes muted. The outermost edge of this vast envelope is called the heliopause, the point where the sun's influence effectively ends and the interstellar medium takes over. At this boundary, pressure from outside space balances the solar wind from within. This balance is dynamic, shifting slightly as the sun's activity rises and falls over its 11-year cycle, and as the interstellar environment varies. But the overall boundary remains stable over long periods, maintaining a smooth, rounded form shaped by the sun's motion through the galaxy. It is not a wall, but a soft gradient, a region where energies meet and equalize. Inside the heliosphere, planets and small bodies experience protection from many of the energetic particles that roam the galaxy. The heliosphere acts as a shield, reducing the flux of cosmic rays that reach the inner worlds. This shielding effect helps maintain the stability of planetary atmospheres and reduces the exposure of surfaces to harsh radiation. It is a quiet service, performed without interruption over billions of years, a gentle buffer that preserves equilibrium within the solar system. The heliosphere's shape is not perfectly spherical. It stretches slightly in the direction opposite the sun's motion through the galaxy, forming a tail-like extension. This tail is not a sharp structure, but a diffuse region where solar wind particles trail behind, carried along by the sun's slow drift through the Milky Way. This motion, too, contributes to the system's calm. The Sun moves through the galaxy at a steady pace, circling the galactic center once every 225 to 250 million years. This slow journey shapes the heliosphere's contour, creating a gentle asymmetry that echoes the balance between internal and external forces. Beyond the heliopause, the interstellar medium itself becomes relevant. This environment is not empty. It contains sparse atoms, dust, and magnetic fields stretching across light years. Though faint, these components exert a subtle pressure on the heliosphere, maintaining the boundary and influencing its motion. The relationship between the heliosphere and the galaxy is not static. As the Sun moves through different regions of the Milky Way, encountering variations in density and magnetic fields, the shape and size of the heliosphere shift slowly. These changes unfold over tens of thousands of years, creating long rhythms that ripple through the solar system like distant echoes. Within this vast region, the Voyager probes continue their patient trajectories. Voyager 1 crossed the heliopause in 2012. Voyager 2 followed in 2018. Their instruments detect the quiet transformation of space beyond the Sun's influence. Changes in particle density, magnetic orientation, and cosmic ray flux. What they reveal is not turbulence, but smooth gradients, subtle transitions, and soft shifts in pressure. The environment outside the heliosphere is calm in its own way, shaped by the faint energies drifting between stars. The Voyagers, powered now by dwindling radioisotope generators, continue sending whispers of data across billions of kilometers, messages that take more than 20 hours to reach Earth. Their journey itself has become part of the solar system's serenity, a slow, patient exploration that unfolds with no urgency. The existence of the heliosphere underscores the idea that the solar system is not an isolated bubble, but a region defined by interaction. Its boundaries form through balance between the outward breath of the Sun and the inward pressure of the galaxy. This equilibrium mirrors the smaller scales of balance seen in orbits, rings, and atmospheres. In each case, calm emerges when forces meet and settle into predictable patterns. The heliosphere simply expresses this principle at the largest scale available. Even the solar wind, though variable, follows long rhythms tied to the Sun's magnetic cycle. Every 11 years, the Sun's magnetic field flips, creating changes in the wind's intensity and structure. These variations propagate outward, influencing the heliosphere's size and shape. Yet because the distances are so great, the effects smear out over vast volumes of space, smoothing what might seem abrupt into subtle shifts. Over the decades it takes for changes near the Sun to travel outward, fluctuations become gentle undulations, blending into the overall pattern of equilibrium. In this outer region, the sense of time changes again. Processes that occur quickly near the Sun become stretched across ages. Particles drift for years before reaching a boundary. Energies blend and disperse across unimaginable distances. Even light takes more than 4 hours to reach the heliopause and return as a reflection. These timescales encourage a perspective where the solar system feels like a slowly breathing organism, its boundaries expanding and contracting with cycles that span millennia. The heliosphere plays another quiet role. It shapes how cosmic rays reach the inner planets. These high-energy particles, originating from distant supernovae and galactic processes, would stream inward freely if not for the heliosphere's magnetic influence. Instead, they are deflected, slowed, or redirected by the complex fields within the solar wind. This filtration helps maintain atmospheric stability on worlds like Earth, preserving the conditions needed for long-term balance. Once again, The system maintains itself through interactions that appear gentle but are deeply effective. The interplay between the solar wind and interstellar medium also creates faint emissions, energetic neutral atoms formed when charged particles exchange electrons. These atoms travel back toward the inner solar system, carrying information about the boundary region. Spacecraft detect these signals, using them to map the shape of the heliosphere indirectly. Even these emissions, created through invisible exchanges, reflect the harmony of interacting forces. They are not bursts of energy, but quiet messengers drifting across enormous distances. Imagining a drift across the heliosphere is imagining a journey through a realm where intensity fades into subtlety. The solar wind weakens gradually, its particles slowing and mixing with the interstellar environment. Magnetic fields twist gently, forming patterns that shift on timescales too long to follow. The sun grows fainter, the galaxy grows clearer, and the sense of direction becomes less tied to a single source. The transition is smooth, not abrupt, a reminder that boundaries in the cosmos often resemble gradients rather than sharp lines. The heliosphere teaches that calm is not the absence of influence, but the balancing of many faint influences together. It is a large-scale expression of the same principle that governs the orbits of planets and the drift of moons, equilibrium through motion. Even at this distant frontier, where the sun's authority wanes, the solar system finds stability. The forces that shape it are gentle, persistent, and expansive. Beyond the heliosphere lies the deeper interstellar medium, where the solar system becomes a traveler among stars. But before stepping into that vastness, the story of the solar system turns inward again, returning to its origins, to the swirling disk of gas and dust that once spun around a newborn sun and gradually found its way to balance. Long before the planets settled into their present orbits, long before moons found their rhythms or icy bodies drifted to the system's distant edges, the solar system existed as a cloud, an immense, slow-spinning nebula of gas and dust. It was neither ordered nor chaotic, but something in between, a place where gravity, motion, and emptiness were beginning to negotiate the balance that would eventually define everything. To understand the calm of the solar system today, it helps to look back at the quiet processes that shaped its birth. For even in its earliest days, when turbulence still stirred the nebula, the seeds of equilibrium were already being planted. The solar nebula likely formed from the remnants of older stars, dust grains, icy fragments, and gas enriched by countless cycles of stellar life and death. These materials floated through the galaxy until a gentle compression, perhaps the ripple of a distant supernova or the passing wave of a galactic arm, caused the cloud to contract. As it shrank, gravity drew it inward and its rotation accelerated, forming a disk around a dense central region. This disk, spinning slowly on astronomical scales, became the cradle of the future solar system. Light had not yet formed. There was no sun, no planets, no moons. Only a growing concentration of matter spiraling toward balance. In time, the central region grew dense enough for nuclear fusion to ignite, and the newborn sun began to glow. At first, its light was weak compared to the brilliant lantern it would later become. Yet even in its infancy, the sun exerted a stabilizing influence. Its gravity anchored the entire disk, drawing material into orbits that followed predictable paths. Closer to the sun, dust grains collided and stuck together, driven by weak electrical forces and gradual motions. Farther out, ice particles clumped into larger bodies. Across millions of years, these grains grew into pebbles, then stones, then boulders, each step subtle, each movement incremental. The early solar system was not quiet in the explosive sense, but it was quiet in the sense of time. Collisions happened frequently, yet most were gentle by cosmic standards. Two objects might drift for centuries before touching, their trajectories influenced by gas flows, sunlight pressure, and the slow spiral of the disk. When they collided, they merged more often than they shattered, forming larger bodies that continued the cycle. This accretion process, though fundamental to planet formation, unfolded with a patience that defies imagination. Even in these early stages, motion followed principles that would later guide planets in their orbits. Balance, interaction, gentle convergence. As the disk thinned and cooled, protoplanets emerged, embryonic worlds orbiting the young sun. Some grew quickly, gathering mass through repeated collisions. Others remained small, destined to become asteroids or comets. The giants formed farther out, where ice and gas were abundant. Their massive cores accumulated thick atmospheres of hydrogen and helium. These planets grew large enough to influence neighboring regions, creating zones of stability and instability similar to those found today. Their gravitational fields shaped rings, sculpted gaps, and directed the migration of smaller bodies. Even during formation, they were guardians of equilibrium. The inner solar system evolved differently. Close to the sun, temperatures were too high for ice to survive, limiting the materials available for planet building. Here, rocky planets coalesced from silicate dust and metallic grains. Their formation involved countless impacts, but as time stretched forward, the collisions grew less frequent. Eventually, orbits stabilized, interactions softened, and the rocky quartet, Mercury, Venus, Earth, and Mars, settled into their long-term paths. The calmness observed in their orbits today reflects the gradual smoothing of early turbulence. One of the most intriguing aspects of this formative era is the role of migration. Planets did not form in the exact places where they orbit now. Instead, they drifted slowly through the disk, influenced by gravitational interactions with gas and smaller bodies. These migrations were not sudden. They resembled slow tides, moving worlds inward or outward over millions of years. Jupiter likely shifted inward before gradually moving back, shaping the structure of the asteroid belt. Saturn, Uranus, and Neptune also migrated, leaving behind resonances that influenced the arrangement of Kuiper belt objects. Even this dynamic era demonstrates the delicate interplay between forces. Large changes accomplished through countless small interactions. Every planet, moon, and fragment in the solar system carries evidence of this early history. Craters on Mercury, Mars, and the Moon preserve the imprint of intense but ultimately self-limiting bombardment. Once the disk thinned and most debris cleared, impacts slowed dramatically. The inner worlds, once pummeled by frequent collisions, now follow calm, predictable orbits. What was once a region of constant change became a region of long stability. In the outer solar system, the same story unfolded with different ingredients. Gas giants accumulated mass so quickly that they captured swirling gases from the disk, forming thick atmospheres layered with clouds. These atmospheres settled into bands shaped by rotation and heat. Moons grew from debris in their orbits, some forming in place, others captured from passing objects. Rings formed and reformed, settling into their present patterns through gravitational interactions that smoothed sharp edges into gentle curves. Over time, the outer system found its own form of calm, sculpted by tides, resonances, and the gentle shaping of sunlight. As the nebula faded and the solar system cleared, the sun grew brighter. The balance between light and shadow began to define climates and seasons on planets. Surfaces cooled or warmed depending on composition and distance. Atmospheres formed through volcanic outgassing, cometary delivery, or chemical reactions. Magnetic fields arose from internal churning, adding new layers of protection and interaction. Each of these developments unfolded slowly, contributing to the stability that now characterizes the solar system. Even the Oort cloud, a hypothetical swarm of icy bodies far beyond the Kuiper belt, owes its existence to these early years. During the formation of Jupiter and Saturn, many small icy bodies were scattered outward. Some were flung into long, elliptical orbits that kept them bound to the Sun through faint gravitational threads. Over millions of years, these objects accumulated into a vast, spherical shell. Though their paths are influenced by passing stars and the galactic tide, they remain part of the solar system's extended calm, a distant halo of barely moving bodies that respond only to the softest of forces. When viewed from the perspective of formation, the solar system's serenity is even more remarkable. What began as a swirling, collapsing cloud became a structured, balanced system through processes that required no sudden interventions. Gravity gathered matter. Motion smoothed turbulence. Interactions redistributed energy. Over immense spans of time, the system naturally evolved toward stability. The planets found their places, the moons aligned, the belts formed, light and shadow settled into gradients that define climates and environments to this day. The central idea that calm emerges from balance gains a deeper meaning here. The solar system's formation was not a perfect or immediate process. It was shaped by trial, adjustment, drift, and repetition. Regions of instability gave way to regions of stability. Collisions that once altered paths later became rare. Forces that once dominated eventually balanced each other. The architecture of the solar system is therefore not static. It is the result of long, evolving equilibrium. Imagining this early era is imagining a dance slowed across eons, dust spiraling inward, pebbles clumping silently, worlds emerging grain by grain, the sun brightening through its own long settling. Every feature seen today, every orbit, every moon, every quiet region of space, remains a descendant of these gradual processes. With the system now formed and balanced, the final chapter approaches. A reflection on what all these layers of calm mean and how the solar system, in its vast and gentle rhythms, offers a kind of cosmic reassurance that extends into the quiet of the mind. As the journey draws outward from the early nebula and returns to the solar system as it exists now, the vast structure that once felt complex begins to feel simple. Simple not in its mechanics, but in its mood. The worlds, the rings, the belts, the winds, the slow drift of dust and ice all settle into a single impression. A system that has found its balance. Not through stillness, but through motion. Not through uniformity, but through the quiet cooperation of countless rhythms. Everywhere the traveler has drifted, across bright inner worlds, deep gas-borne atmospheres, moonlit plains, icy frontiers, and the dim edges of the heliosphere, the same theme has repeated with different textures. Calm does not come from silence alone. It comes from patterns that endure. It becomes easier now to see the solar system not as a series of isolated destinations, but as a continuous environment with layers that resonate with one another. The sun breathes outward with light and particles. The planets respond with orbits shaped by that breath. Moons follow the sway of their planets. Icy bodies trace slow arcs in regions where sunlight barely reaches. And all of it is held within the faint, expansive cocoon of the heliosphere. The entire structure becomes a single, immense instrument, tuned by gravity and time. When one steps back far enough, beyond the particulars of atmospheres and seasons, beyond the geology of plains and canyons, beyond the sway of rings and tides, a larger perspective emerges. The solar system is a story of settling. It began in turbulence, in a cloud that shifted and folded under its own weight. But over billions of years, it has matured into a place defined by stability. Each orbit is a thread woven through the tapestry. Each world contributes a tone to the harmony. Even the smallest fragments play their part, drifting along pathways shaped by forces too patient to notice in the short term. From this wide vantage, the solar system becomes a reminder that balance is not static. It is active. It breathes. It adjusts. Even today, tiny influences accumulate. Sunlight nudges an asteroid gently inward. A moon's tidal pull alters the spin of its planet by a fraction. The solar wind swells and shrinks the heliosphere with its slow rhythms. None of these changes disrupt the overall harmony. Instead, they reinforce the idea that equilibrium is something the system continually renews. Balance is not a destination, but a process, one that has lasted billions of years and will continue long after the present moment has passed. In the inner regions, the quiet interplay of sunlight and shadow remains constant. Days brighten and fade, seasons cycle, winds rise and fall. Though these patterns differ from world to world, each one is shaped by the same underlying gradients of light and gravity. Farther out, the giant planets move in their grand arcs, taking years, decades, or centuries to complete a single orbit. Their moons continue their gentle dances, following cycles that repeat with quiet precision. Beyond them, the icy frontier drifts almost imperceptibly, shaped by faint sunlight and the soft gravitational pull of Neptune. Still farther lies the heliosphere, an immense buffer where the sun's influence stretches until it quietly dissolves into the galaxy. The more one drifts through these layers, the more the central idea reveals itself. Cosmic calm arises from the quiet balance between motion and emptiness. Motion alone, without emptiness, would be crowded, chaotic, turbulent. Emptiness alone, without motion, would be static and bare. But together, they create the conditions for harmony. There is space enough for everything to move without collision, and movement enough to ensure nothing drifts without purpose. The solar system does not need to enforce order. Order emerges naturally from the distribution of mass, the flow of light, and the patience of time. Human life unfolds on a scale so much smaller than the solar system that its rhythms can feel overwhelming by comparison. Days pass quickly, seasons come and go. Generations rise and fall, challenges arrive with speed. Yet the solar system, seen as a whole, offers a quiet antidote to this sense of hurry. It demonstrates that stability is possible even when everything is in motion. That calm can arise not from freezing the world into stillness, but from allowing forces to balance themselves gently over time. That the universe itself moves at a tempo slow enough to soften the mind. As the imagination lingers on Earth's place within this grand arrangement, a subtle feeling of reassurance emerges. Earth is not separate from this cosmic calm. It moves with the same patience as the other planets, its orbit guided by the same rules, its rotation steady, its tilt stable across epochs. The moon tugs on its oceans, sculpting tides in a rhythm as old as life. Sunlight warms it in cycles that support seasons and climates. Even its atmosphere, complex and dynamic as it may seem, participates in long, settling processes shaped by the balance of heat and light. The planet is part of the system's harmony, not an exception to it. Stepping even further back, one may imagine drifting above the plane of the solar system, a thin disk where the planets trace concentric paths around the sun. From that vantage, everything appears slow, deliberate, and peaceful. The sun glows gently at the center. Earth moves steadily along its track. Mars drifts at a slightly slower pace. Jupiter arcs in the distance like a lantern circling the edge of a wide clearing. Rings sparkle faintly around Saturn. Uranus and Neptune carve wide, serene loops. Far beyond them, Pluto and its companions move like tiny embers in a dim expanse. This view, quiet and expansive, holds an almost timeless calm. And then, even farther away, the heliosphere appears like a soft boundary, a faint, rounded shape that glows only through the interactions of particles and magnetic fields. It is not a wall, but a transition, an outer breath, where the solar system softly meets the galaxy. Everything within it is part of one continuous motion. Everything beyond it stretches into deeper darkness. The scale, though immense, does not overwhelm. Instead, it soothes. It shows that the solar system is not in conflict with itself. All its motions support one another. Gravity and emptiness co-create the stage on which worlds drift. Time smooths every rough edge. Light ties the system together with a gradient so gentle it fades rather than ends. As the mind settles into this understanding, the solar system begins to feel less like an environment of distant or exotic places and more like a single, continuous space. A home stretched wide across billions of kilometers. A space shaped by patience. A space shaped by balance. A space in which nothing needs to rush, because the rhythms are older than anything that measures them. Even the knowledge that the solar system will continue to evolve, slowly brightening sun, drifting orbits, distant changes in the galactic environment, does not disturb the calm. These shifts unfold across timescales far beyond human concern. They are part of the system's ongoing balance, not threats to it. Just as landscapes on Earth change over centuries without breaking the planet's continuity, the solar system changes over aeons without breaking its harmony. And so the journey ends not with an abrupt conclusion, but with a gentle fade. The worlds settle into their familiar orbits. The sun continues to glow. The heliosphere drifts through the galaxy like a softly lit lantern. Everything moves. Everything rests. Everything persists in quiet balance. Let the breath slow. Let the thoughts soften. Let the vastness above become a place of comfort rather than distance. The solar system endures in its quiet equilibrium, and within that equilibrium, a kind of reassurance unfolds. That balance can be gentle, that time can be patient, and that even the largest structures in the universe can move with the softness of a lullaby. Good night.